Hello everyone and welcome to this session on Azure AI. My name is Tegan Riffat and I've been working at Microsoft for approximately 2.5 years as a partner technology strategist. Now, like many of you I suspect, I would not call myself a quote-unquote data scientist by any stretch of the imagination, and so the idea of being able to tap into modern AI capabilities regardless of skill level is something that I personally find quite exciting. That said, if you are a proficient data scientist in the true sense, stay tuned as we will be also covering how Azure can make you more productive with support for tools, frameworks, and environments you are already likely very familiar with. My hope by the end of this session is that we'll have a greater appreciation and understanding of the variety of modern AI capabilities we have in Azure, and specifically how you can democratize AI within your organization. So when I first started compiling this presentation, it really forced me to think through, in today's day and age, what is a data scientist? While I had my preconceived ideas, as I've worked in the business intelligence domain for about 10 years prior to joining Microsoft, I have friends and family that also work in this space, but I thought it would be an interesting experiment to get an external perspective by collating the free text job descriptions for all open listings that match the search term data scientist and glean an understanding of what the market is currently looking for. This word cloud visualizes those key phrases with size based on the percentage of listings those phrases appear and color based on categorization. So you can see there, for instance, we have a lot of the programming languages all in the same color. Similarly, we have all the qualifications like PhD, degree, masters, also in the same color. Now, there were a couple of noteworthy insights worth mentioning. First off, we had a whopping 82% of the listings who were looking for individuals with Python skills, particularly in popular data science libraries such as Pandas, NumPy, and PyTorch. 38% of listings were looking for individuals with cloud experience, and that's experience with one of the hyperscale cloud vendors such as Microsoft's Azure platform. And then finally, 55% of listings were looking for some type of formal degree, whether that be a PhD, a master's, or Bachelor of Science. Now, this exercise really helped me formulate a picture of what the ideal candidate with preferred areas of study, formal qualifications, programming experience, and so on. Now, overlay all of this with the required business domain knowledge, and the conclusion that I came to is that what we're actually looking for is one of these. Now, while this might be great for a handful of people within your organization that resemble anything close to this, but what about everybody else? And this really brings us to the intent behind what Microsoft is trying to achieve. While we provide the platforms and services to empower your existing data science teams to be more productive in familiar development environments with support for all the popular frameworks such as PyTorch, TensorFlow, and Scikit-learn, we are simultaneously investing in a number of areas to democratize AI to individuals of all skill levels. While Microsoft have a vast range of products and services that fall within the artificial intelligence domain, our key offerings really in this space from Azure are categorized under one of these three pillars: apps and agents, knowledge mining, and machine learning. So let's start off with apps and agents, and specifically Azure Cognitive Services. So with Azure Cognitive Services, we really are bringing AI within the reach of every developer. Azure Cognitive Services represents our growing set of pre-built models ready to be consumed. There's no need to understand data science or hold a PhD. Microsoft has done all the hard work. This is our model, your data. All it takes is an API call to embed the ability to see, hear, speak into your applications without requiring any machine learning expertise. You can see we cover a number of different domains from language, vision, and speech. And most recently, we've introduced a new category of cognitive services referred to as decision, with capabilities such as anomaly detection, content moderation, and personalizer. Personalizer helps create rich, personalized experiences for every user by choosing the best single content item to show each user based on real-time information. This is great in helping surface the right content to the right user at the right time, helping boost overall customer satisfaction. Under Vision, we have Ink Recognizer. So Ink Recognizer has the ability to recognize digital ink and handwriting and pinpoint common shapes, and convert this input into machine-readable text. Under Speech, we have Conversation Transcription. Conversation transcription is a speech-to-text solution that combines speech recognition, speaker identification, and sentence attribution to each speaker to provide real-time and/or asynchronous transcription of any conversation. So with new innovations being added all the time, Azure Cognitive Services really does represent the most comprehensive set of pre-trained AI, ready for developers to consume to infuse intelligent capabilities within existing and net new applications, such as speech-to-text, sentiment analysis, facial recognition, and much, much more. Next up, we have knowledge mining. So when data is quite structured, whether that be in rows and columns within a CSV file or a table stored in a relational SQL database, it is relatively straightforward to query that data, ask questions, and derive actionable insights. But what about those insights that are laying dormant in the growing volumes of unstructured data, such as Office documents, images, audio, and video files? So this is now possible with a service that we've got called Azure Cognitive Search. It is the only cloud search service with built-in AI capabilities that is able to enrich all types of information to be able to easily identify and explore relevant content at scale. So what does an Azure Cognitive Search pipeline typically look like? Well, first, we need to ingest this unstructured data into our cloud estate. This may reside in a general purpose data store such as Azure Blob Storage. These documents are then cracked open and enriched using a number of AI services across vision, speech, and language, such as OCR, language detection, key phrase extraction, and more. Finally, the output of this enrichment process is surfaced and materialized as a searchable index, which can be infused within your own applications to allow for data mining and exploration. In addition, the cognitive search functionality can be further extended with the concept of a knowledge store, currently available in public preview. So the knowledge store enables us for further independent analysis or downstream processing by enabling connectivity with analytics and reporting tools such as Power BI or Power Query. Similar to Azure Cognitive Search, we have another knowledge mining capability specifically tailored to extracting data from forms. You can start with any type of form and quickly train and deploy a custom model using simple REST API calls to extract the underlying data. So simply train a custom model off of a small training dataset. That may be a sample of 5 pre-filled in forms. Form Recognizer will then learn how to identify and extract key value pairs and table data. Once trained, the model can be used to programmatically extract data from forms it's never seen. Finally, we have machine learning. So when it comes to machine learning in Azure, there are 3 authoring experiences we have sitting on top of the Azure Machine Learning Service that enables us to build, train, and deploy machine learning models faster. On one end of the spectrum, we have automated ML. This is great for business domain experts who know a lot about the data, but they don't necessarily know much about ML algorithms or code. The automated ML user interface allows those customers to automatically generate models for their data in a no-code user experience. Simply select your dataset, specify the column that you would like the model to predict, and finally select the task type. Is this classification, is it a regression problem, or is it time series forecasting? Next up, we have Azure Machine Learning Designer, aka Drag and Drop ML. This is great for people who are learning machine learning concepts and want to build models themselves but aren't necessarily proficient Python coders, or the proficient data scientists looking to rapidly prototype an idea without having to write custom code. And then on the other end of the spectrum, we have support for Jupyter notebooks directly within the Azure Machine Learning Studio interface. This is ideal for developers and data scientists who have a preference to writing code and want to build models using the tools they are already familiar with. And we've got the added flexibility of switching at any point to the native Jupyter Lab or Jupyter Notebook experience. Now, regardless of which authoring mechanism is chosen, each tool is fully integrated with the underlying Azure Machine Learning Service. This is great because it provides us a unified management experience, versioning and tracking for models, pipelines, and endpoints to help facilitate ML ops, and support for the Azure Kubernetes service as a compute target for model inferencing. So let's walk through an example where we would like to build a model to predict the value of a car. The typical model creation process can be quite time consuming. We need to understand, which subset of features will have the greatest degree of influence on the performance of our model, select an algorithm to train our model. We need to fine tune and optimize our hyperparameters. And it's a combination of all of this that can lead a model to a particular result, and then we must make subtle adjustments, rinse, repeat, and compare. We'll then iterate over and over until satisfied and we have found our ideal performing model. Now, in contrast, with the Azure Machine Learning Service and the automated ML experience, we simply select our data, select the target column that you would like to predict. In this case, we'd like to predict the price of a car, and define the problem type. As we're trying to predict the numeric value of the car, this would be regression. Azure ML will essentially brute force the best model by automatically generating new features and testing a number of different model scenarios in parallel. This is great for the novice ML user who may lack ML expertise but also brings strong business domain knowledge, or the ML expert who is looking for automated ML to simply fast track the model creation process. So finally, if you're eager to learn more, I would suggest heading on over to aka.ms/AML-free, where you can get started with your first Azure subscription and some free credits. And if you're interested in learning more about Azure and getting hands-on with the technology, simply head on over to Microsoft Learn. All content is free and it's available on demand, so you can learn at your own pace. And we have material catering for beginners all the way up to experienced professionals. There's also gamification baked in along the way with badges and trophies waiting to be unlocked. So to get started, visit aka.ms/learn. And with that, I'd just like to say thank you.